So again, we continue full speed with one of the last two sessions in English. And this time we are going to talk about a quite interesting subject, because we are going to talk about where hydrogen is consumed today, right? You need to be aware, to keep in mind that hydrogen today is $110 billion business worldwide, and that's mostly a feedstock for the industry. It's using hydrogen in various industrial processes. So obviously, the first thing we need to think about is how we can decarbonize these processes. So the best way to address that question is to have professionals who are in this business of using hydrogen massively in metallurgy, in different chemical processes, whatever. And with some actors who are developing the technologies that will help us to decarbonize this industrial feedstock. So just to keep in mind as well, in France, the last law, PPE, has written that we need to achieve 10% decarbonization of the industrial hydrogen in France by 2023. So this means 90,000 tons a year of hydrogen. And that's just supposed to be a beginning. So to start with, because we have two invitees from, one is coming from Italy, right? Another one is coming from Germany. So from in Italy, we have ENRICO MALFA from TENOVA. And we have Tristan KRETSCHMER. Am I correct? Correct. From THYSSENKRUPP. We will start with Enrico. Enrico, you are going to explain to us, first of all, what is TENOVA, because it's a big player with many, many branches. And then from there on, we will start to discuss about the way you see hydrogen and what you are doing with that. And please keep close with the mic.
Thank you very much. TENOVA is a part of THYSSENKRUPP. In the THYSSENKRUPP, one of the main business is steel production with two main companies. One is Tenaris, that is producing pipe that we can use for transportation, also for hydrogen. And then our is Ternium, that is producing flat plate. TENOVA is the engineering part, so we have developed a solution during this year for the steel and mining sector. And our main pillars are sustainability, are safety, are reliability, and innovation. We are in a good position, I think, for the decarbonization of the steel industry, because in our portfolio we have several technologies that are ready also today to use hydrogen in a massive way.
Okay, so actually you're not only a user of the feedstock as a steel producer, but you have also in your group a part that you do work with as a Norwegian director to really develop the new technologies that will help you decarbonize. Am I correct?
Yes, absolutely yes. So one of the main technology is related to production of liquid steel. And so in this case, we have developed, starting from 16, a new process that is the direct reduction process that today use natural gas as a feedstock, but the gas that react with iron ore is basically already today more than 50% hydrogen. So we start from natural gas, we have some reforming process, and so the real feedstock is a syngas that contain already 50% of hydrogen. So to increase this percentage of hydrogen is not a so big deal.
Okay, for everyone to be clear about that, because I guess producing steel is maybe is not something that you don't you know. I didn't know. So reduction is about coming down to the metal, and you're using a lot of hydrogen feedstock for that.
Yeah, basically we have three processes for steel production. One is the more traditional, the oldest one that start from iron ore. And from iron ore we have to obtain iron. And to do this process, today we use coal. Because carbon is a reduction agent to move from oxide to iron. The opposite side, we have another process that starts from already from steel scrap, recyclable steel in line with circular economy. So in this case, we use electrical energy mainly to melt already the steel and to produce the steel. In the between, we have this new process that is based on natural gas today because both carbon and hydrogen are able to reduce the iron ore. So we can move from 100% of carbon up to 100% of hydrogen as gas.
So basically the second process is burners, right? Or
yes.
Yes,
okay.
no?
Burn is not only a source of energy, but is react with iron ore to produce iron.
Yeah.
Okay, so it's not just fuel. It's not just for giving energy, but is for reducing iron ore to iron.
Okay, so if I understand well, the first step for you is to increase the amount of hydrogen in the process.
Okay, yes, we can do because hydrogen is a perfect reduction agent for iron ore.
Yeah, okay. So now to get that hydrogen, we need to, well, so far most of this hydrogen is coming from reforming. It's a steam methane reforming hydrogen, what we call sometimes gray hydrogen, right? So another way to increase the decarbonization is actually to decarbonize the hydrogen itself.
Yes.
Correct?
This is correct. Right.
So how do we do that?
One alternative to steam methane reforming, for example, would be producing hydrogen via water electrolysis. So ThysSENKRUPP has large-scale water electrolyzers in their portfolio. We are based on alkaline technology. And the big advantage CO2-wise is that when you produce hydrogen coming from SMR, with every kilogram of hydrogen produced, you also emit 10 to 11 kilogram of CO2. So when you produce that hydrogen from water with renewable electricity, the emission is zero.
Okay, so ThysSENKRUPP and electrolyzers, tell us about that story.
Correct. So ThysSENKRUPP is also a large enterprise. We have like 160,000 employees, and you may know us from the steel, from the cement industry as well. And one pillar is the industrial solutions, under which, in a joint venture with Industrie TENOVA, we have formed the ThysSENKRUPP Chlorine Engineers. We use decades of knowledge coming from the chloralkaline technology, from the chloralkaline electrolyzers, to build our water electrolyzers.
How long have you been in this electrolysis industry?
I've been in the hydrogen business for now 12 years, I would say. In the electrolyzer business, I've been for 7 years.
For 7 years?
For 7 years, yeah.
And what kind of size and of system are you targeting and addressing?
Well, we started with fairly small pilot projects in the market, not just ThysSENKRUPP, but in general. So there was like 50 kilowatt, 1 megawatt systems, but this is something where you cannot realize a leverage for the market, and especially not for the industry. The industry demands high amounts of hydrogen, electricity, energy in general. So when we speak of decarbonizing the industries, we will need several hundreds of megawatts of electrolyzers. So for example, ThysSENKRUPP has the capability to deliver 600 megawatts of water electrolyzers every year.
So, TENOVA, have you already considered the electrolyzers as an option?
Yes, this is, we speak about decarbonization looking at green hydrogen. On the other hand, it's no sense we can use natural gas directly. So hydrogen has a sense for us only if come from green hydrogen to reduce dramatically the CO2 emission, because with a process that we described before, with 100% hydrogen, we are able to reduce at more than 80% the present CO2 emission from a traditional steel plant. Of course, as a colleague said, the scale is very big. So to give you an idea, for 1.5 million ton of DRI production, that is a medium module for us, we need more than 400 megawatt of electricity. So that are more or less 900 million normal cubic meter per year of hydrogen.
Well,
this is
400 megawatt is quite a big figure, I must say. And you see, the technology is mature. Technology-wise, we can handle that. That's not the problem. The challenge is that the processes are running at their theoretical optimum. And shaping this, reshaping it, meaning transition towards an alternative with electrolyzers, and is also related to the landscape, the location, and how to get this huge amount of electricity towards those locations.
Yeah, and that electricity and the cost of that electricity is very different from one country to another one. So I guess you consider the impact on the total cost of the process. And do you think there is a threshold that is acceptable and above this one is not accessible anymore?
Based on our analysis, of course, the main problem is the cost of electricity. So this is the main driver.
Right.
Okay, of course, carbon tax, CO2 tax has an impact, but the main impact is the cost of electricity. So to be competitive, let's say with today cost of natural gas, we need to have electricity between 20 to 30 euro per megawatt. So
20 to 30
something
euro.
Achievable as a production cost, I think, then depend of taxation in different country, cost of transmission, and so on.
I mean, what's important to point out is that this electricity must be renewable, right? So it must come from either solar or wind,
or winds.
hydropower. So 2 to 3 euro cents per kilowatt hour is achievable for the production. But I would say the problem is that, or the challenge is the taxes and fees that come on top of that.
Exactly.
Yeah, so especially the transport taxes that if they apply, so one of the way you can act on that is really to get the right conditions to access to electricity that is
so the main incentive to promote this transition is just to look at taxation of electricity, because this is crucial.
Right.
I think.
I mean, as an electrolyzer provider, we have several leverages to, let's say, support our customers and help them achieving their goals by decarbonizing, right? So one is make the system more efficient, which is what we do. We spend every year a fairly high amount in innovation of our electrolyzers. Second is make them more efficient, so they need less electricity for the same amount of hydrogen. But of course, the business case then comes to certain limits where you need political regulations. And I mean, the Capex, the investment for such a technology is one thing, but it's not that big. If you run an electrolyzer for 30 years, which is feasible, the technology is mature enough to reach that, the Capex on the hydrogen price is fairly low. The big impact is then on the regulation
30 to 40%, I think. You
for
would not
the,
say
for
that.
The Capex? For the Capex? No,
Yeah,
I think 30 to 40% is quite high. I think this is too high.
Okay. Are you expecting from the regulators or from Europe to do the maybe a kind of effort to put in place certain mechanisms to accelerate that decarbonization? Because if we don't have the appropriate mechanisms on the electricity market, it's going to be tough.
Correct. I think the announcement of the new Green Deal is a huge first step that gives us hope that we achieve that. Of course, I mean, the fees must be in accordance with the industrial needs. I mean, the current system is based on 120 years of industrialization with fossils, and this needs to be reshaped. And that is a big challenge. But I think that on European level, we are now taking the right lane to achieve that, to make it better and make it more attractive for companies to invest in green technology.
And as major industrials in Europe, are you bringing this message to the Commission?
Yes, of course. we are also working with European Steel Technology Platform to produce a roadmap. And okay, one route for decarbonization, of course, is hydrogen and renewable. Our route is carbon capturing and usage. But one of the main targets is to pass the message that the technology is available. The Capex also for plant itself is not really a big deal. Of course, we need infrastructure that allows to have a competitive cost for production of steel. On the other hand, steel industry in Europe can do the decarbonization, but will be out of the market. So,
okay.
This is
To conclude, I would like to ask you both. If we think about a 100% decarbonized process, when do you see that happening? In how many decades from now? Or
how many decades from now? Hard to say. I don't think we have the time for decades, I must say. I mean, ThyssenKrupp...
that's a good answer. Thank you.
Right. I mean, we obliged ourselves to cut our emissions by 30% in the year 2030 and be CO2 emission-free on scope 1, 2, 3 by 2050. And this is achievable, and this is also that follows the Paris Agreement. And I think this is more than enough time to have a safe and sound industrial change that can we cope with.
Enrico.
Okay, 3 points. One is the first ton of steel produced with hydrogen, so the first ton of green steel will be produced by the end of this year in the hybrid project in Sweden, and the reactor come from TENOVA. Then we discussed with several steel producers, for example, with Skitter in Salco's project, and there is a plan to replace the old technology with a new one step by step. So let's say that the target for 100% or 90% reduction of CO2 is 2050, but with a gradual step. The first thing to say is that this direct reduction technology is flexible. So you can do an investment starting from natural gas, and then this investment is not lost during the year, because you can increase your hydrogen step by step.
Okay.
So this is not an advantage.
All right. So you're confident we can make it?
Definitely.
Okay.
Very confident.
Right. Thank you very much. That's a good message to conclude. Thank you very much. Bye. Have a good day.